We're looking at section 4.4 now. 4.4 is going to deal with applications of logarithms as well as change of base theorem. So there's two logarithms that are kind of special. Log base 10 of x, which we write as log of x. So if you see a logarithm without a base, it's actually base 10. This is called common log. And then log base e of x, we write that as ln of x. And this is called natural log. So we start with just a quick word problem. They're going to tell us pH is equal to negative common log of H3O plus, which our book tells us is something called a hydronium ion. And then depending on the concentration of this, we can get the pH. So they don't really have too many questions in the homework about this, but this pH equation is kind of one of the big pushing points in the textbook, I guess. So we're going to cover it real quick and see it's pretty easy to use. So the way that they do this, for this example, we'll say for part A, suppose the H3O plus amount is equal to 2.5 times 10 to the negative fourth power, and we want to find the pH. And then part B is going to be the reverse. Suppose the pH is equal to 7.2, and we want to find the H3O plus amount. So for part A, it's extremely straightforward. We say, well, the H3O plus is 2.5 times 10 to the negative 4. So we plug that in for the O plus amount. So this is going to be negative common log of 2.5 times 10 to the negative 4. Common log and natural log, those are two buttons you guys will have on your scientific calculators. So at this point, all you need to do is type it into your calculator. I'm going to use Desmos again because that's easier to kind of see what I'm doing. So we get negative log of 2.5 times 10 to the power of negative 4. And the book says for pH, you're supposed to round to the tenths place. So we get 3.60, some other stuff. So we say the pH is 3.6. And then part B. So this time they tell us the pH, so they're telling us the left-hand side of this equation. So the pH is 7.2. That equals negative common log of H3O plus. So step one, I need to get the logarithm by itself, and in order to do that, I just need to move the negative sign across. So I'm going to divide both sides by negative 1. This will give me negative 7.2 equals common log of H3O plus. And from what we said at the beginning, common log is actually log base 10. So I'm going to write the 10 in here because I'm going to convert this over from logarithmic form to exponential form. So the 10 is sort of our A, H3O plus is our X, and this negative 7.2 is our Y. So we get A to the Y equals X. So 10 to the negative 7.2 is X. Let's see if that turns into anything nice. So it gives us 6.3 times 10 to the negative 8. Not really that nice. That is, I wrote X here. X is actually the H3O plus amount. So that equals, that X is actually a stand-in for the H3O plus amount. So now I have I think that's hydronium ion concentration. I think it's what the H3O plus represents. But with pH, that's how to, if you're given a H3O plus amount, if you're given that, that's how you use the equation to get the pH. And if you're given the pH, this is how you kind of work in reverse to get the concentration. After this, you guys, section 4.4, homework's going to have you guys calculate logarithm of a couple things and natural log of a couple things using your calculator. So they want to know what's log base 12, or what's natural log of 1 over e to the 7th, or like what's natural log of 15. And these are types that you can't really do in your head because logarithm's base 10, so you think 10 to what power is 12? Well, if it was 100, 10 squared is 100, or if it was 10 itself, 10 to the first power is 10. But there's no real nice power to get from 10 to that power is 12. So these are types you just do in the calculator. And when you guys go through and do these, we just want to say what's log of 12. And log of 12 is 1.079. We'll round up from 8 to 2. So 1.0792. So it's about equal to 1.0792. It's not exactly, but it's approximately. So if we want to do natural log, so that's ln. That's natural log. We want 1 divided by e, and the e is raised to the 7th power. And that ends up being -7. This one we didn't actually need the calculator to do, but could say, well, natural log's base e, so e to what power is 1 over e to the 7th power, and it does make sense that's -7. But on something like 15, e to what power is 15, because natural log is base e, that's going to be a decimal. There's not really a nice way to do that. So you just do it in your calculator, and you get natural log of 15 is 2.7081. So 2.7081, and this is, again, about equal to. It's not exact equal. So your homework's going to have you guys evaluate a couple logarithms by just typing them into your calculator. So that should be really easy. Then the last types from this section use what's called the change of base formula. Let me write this down the same way it's written down in our textbook. So change of base formula. This basically lets you convert a logarithm of one type to a logarithm of a different type. So if we have log base a of x, that equals log base b of x over log base b of a. So when you want to convert a logarithm of base a to logarithms of base b, what you guys do is you get logarithm of the new base of the parentheses part divided by logarithm of the new base of the old base. So this is our change of base formula. I think it's going to be easiest for us if we kind of, when we want to convert over, you guys have natural log and common log as buttons on your calculator. So we're going to convert everything over to natural logs for this section. And so this finishes out with stuff like if you guys want to evaluate, say, log base 3 of 8.2. We don't have a log base 3 button on our scientific calculators. So you kind of get stuck and say, well, I can't really type this into the calculator that I got for the course because it doesn't have a log base 3 button. So we're going to convert this over to a log button that your calculator does have, which your calculator does have a natural log. So by the change of base formula, if I'm trying to evaluate what is log base 3 of 8.2, I can convert it to natural log of the top part divided by natural log of the old base. And now I do have a natural log button, so I am able to type that into my calculator. So here, if we go through and do this, we could say it's natural log at the top. So natural log of 8.2. And then I divide that by natural log of 3. And this will be about 1.9153. So 1.9153. This is about equal to that. So maybe another one of these. If say you want to do log base 1/4 of 15. Again, fourth to what power is 15? There's not really a nice way to do it. I don't have a log base 1/4 button on my calculator. So it's natural log of the top of the parenthesis part 15 divided by natural log of the old base 1/4. Now I can type it in my calculator, and basically I get natural log of 15 divided by natural log of 1 divided by 4. And that'll be negative 1.9534. So negative 1.9534. And maybe one last one of these. Let's say we got log base square root of 7 of 2.4. So again, this will be natural log of the parentheses part, which is 2.4, divided by natural log of the old part, the old base, which is square root of 7. So we go and we just type it into our calculator. Say, what is natural log of 2.4 divided by natural log of square root of 7? And that'll be 0.8998. So all this change of base formula, what we're using it for in this course is basically, you guys, when you get to a type you can't do in your head and you need to do it in the calculator, but the base is base 3 or base 4 or base a fourth or square root of 7, where you guys don't have those buttons, the change of base formula lets us convert it over to natural log. So we have it is able to be entered in from our calculator. And then you just type it in your calculator, round it some decimal places, and that's basically how it works, and that's what you'll need for the homework. And we'll stop there.